Ever feel totally lost looking at Kubernetes diagrams? Don't worry, we're going to simplify it with a shipping port.
Yeah, it can look like this massive, intimidating machine with a language all its own, right?
But I promise you, it's not magic. It's actually a really organized system, a lot like a busy shipping port.
And by the end of this, you'll see exactly how it all fits together to get your apps running.
All right, let's get into it. Here's what we're covering on our little tour of the Kubernetes port.
So, first things first, what does Kubernetes actually do? Well, it's got three main jobs that make it so powerful. It runs your containerized apps, scales them up or down when needed, and handles failures gracefully.
And this whole operation, this whole system, that's called a Kubernetes cluster. Just think of it as the entire port. So a cluster is really just a group of computers, we call them nodes, all working together as one big team.
Now, every cluster has two main parts: the control plane, which is our control tower, and the worker nodes, our fleet of ships.
Let's start with the control plane. This is the brain. It doesn't do the heavy lifting, it just makes all the global decisions.
Inside that control tower, you've got 4 key players, and each one has a super important job. Let's check them out.
First up is etcd. This is the port's official registry. It's the database that stores the state of, well, everything.
It's the one and only source of truth for the entire cluster. You can think of it as the cluster's memory.
Okay, next we have the scheduler. This is our master crane operator. Its job? To decide where every new container goes. And it's really smart about it. It looks at a container's needs and finds the best ship or node to place it on.
Then there's the controller manager. Think of this as the port's management office, making sure everything is running smoothly.
This brings up a huge concept: desired state versus current state. You tell it what you want, and it makes it happen.
So if a container goes down, a controller sees that and starts a new one, automatically. That's self-healing right there.
And last but not least in the control tower, the API server. This is the main entrance, the central command for the whole port.
Literally, nothing happens in the cluster without going through the API server first. It's the ultimate gatekeeper. So a typical flow looks like this. You send a command, the API server checks it, the scheduler assigns it, and a node runs it.
All right, we've seen the brains of the operation. Now for the brawn. The worker nodes are the ships actually doing the work.
These are the machines that run your app's containers. And in Kubernetes, those containers are wrapped in something called a pod.
Now, each of these worker nodes has a few essential agents running on it to manage everything and talk to the control tower.
First, you've got the kubelet. That's the captain on each ship. It takes orders from the control tower to manage its containers.
Then there's kubeproxy, which is like the ship's navigator and handles all the networking rules to get traffic to the right place.
And finally, the container runtime. This is the engine room of the ship. It's the software that actually runs the containers.
And here's a key point. Kubernetes itself doesn't run containers. It tells a runtime, like Containerd or Docker, to do it.
So we've seen the control tower and the cargo ships. Let's bring it all together for a quick recap.
So here's your blueprint. The control plane manages, the worker nodes run your apps, controllers keep things stable, and the API server is the hub. And just like that, you see the system. Not so complicated, right? It's just a well-organized port, doing its job.
If this helped clear things up, make sure to like, share, and subscribe for more updates.